This is going to be review. So I'll go through these pretty quick. I'll show the new ones and take a little longer on them, but I'll kind of jump into right away with what we're looking at. So centripetal force. What is centripetal force? We talked about this already. It's the force responsible for circular motion. So what's the equation for centripetal force? So the equation is this. Fc equals mac. Oh my gosh, it's Newton's second law. Who would have thunk? Now, the problem is we don't know what the centripetal acceleration is most of the time, but we do know the tangential velocity most of the time. So the real equation we're going to use is this one. Fc equals m vt squared over r. That's the equation we're going to use most of the time. But I do want you to see that it is the equation we learned last unit. Like, it's the same equation. And that's because, remember I said centripetal force isn't a new force, it's a net force? Snap, it's a net force. Okay? In what direction does centripetal force act? The force acts towards the center. Towards the center of motion. So why does the centripetal force act in this direction? The reason it acts in that direction is because it needs to change the velocity's direction. So it needs to change the direction of Vt. Okay, so what's an example of the centripetal force? So the string in the pig lab. That was tension. Tension caused the centripetal force. Without the tension in the string, no circular motion happens for the pig. It only happens if there's tension in that string. All right, jump her over to the back. Let's label what a picture is going to look like. So what are our diagrams going to look like? So our diagrams are going to look like the following. First of all, you're going to have a radius. Now, I didn't say that on there, but you're always going to draw the radius. Then what you're going to do is you're going to have the object. I frequently just mark an X. X marks the spot. And then you're going to have a rotational velocity, which is the rotational speed around the circle. So it's how fast it gets around. Then you're going to have your tangential velocity, which is how fast it goes. And that's just in a straight line. And then you're going to have your centripetal force, which is the force acting towards the center. And I just draw it next to the radius towards the center. Something like that. When you draw diagrams, this is what you're going to draw. They're very easy to draw. You draw a circle, you draw the radius, you draw the object as an X, and then you label the velocities it gives you. Okay, helpful note about centripetal force. It's always man, I just cannot talk today. It's always caused by other forces. So it's a net force. It's made up of other forces. And those other forces are things like tension, applied force, friction, etc. So, tension, applied force for the pig lab. Okay? So that was the force for the pig lab. Applied force. My kids love it when I grab them by the arms or the ankles and spin them around in circles. Okay? I don't know why that's fun, but they think it's awesome. So that's an applied force. I hold on to their arms and spin them around. That's an applied force. Friction is how cars turn. Cars move in circle because there's a tension force between the tire and the road. There's a friction force between the tire and the road. So those are some examples of how those applied centripetal forces. Okay, let's talk about the centrifugal force. So what is the centrifugal force? So the centrifugal force describes why objects appear to move out from the center of the circle. So it's why objects appear to move out from the center of the circle. So give an example of this. Okay? Kid on a merry-go-round. Now you're saying to yourself, kids on merry-go-rounds is not exciting. Well, that's because you're not this kid with his crazy father. Okay, there's the kid. See him? See how he's going out from the center of the circle? So that's what centrifugal force is describing. See, he's going out from the center of the circle. There you go. So that's, now you guys are just jealous that you didn't do that when you were little kids. So this is also why they don't make awesome merry-go-rounds anymore, because somebody probably broke an arm that way. So the kid on the merry-go-round, that's your example. So it looks like he's going out from the center. Here's the thing. Centrifugal force is not real. It doesn't exist. It is literally called an imaginary force. Okay? It's not real. So why do objects feel like they're pulled out from the center? We've already talked about this. You already know it. Why do objects look like they're going out from the center? Because it wants to go in a straight line. Inertia. Inertia. So what direction will the object travel if its centripetal force suddenly disappears? It will go straight. Okay, so think about driving in a car. So if you're driving in a car and you make a right-hand turn, so you're going straight, and all of a sudden you turn to the right. What direction does your body want to go? It wants to keep going straight. But because you've already turned the car a little bit, your body is leaning straight, which now looks left. So it feels like you're going out from the center, but what you're really doing is going straight. You're really going straight. The same thing would happen to Earth. If the sun disappeared and there was no more force to hold the Earth in a circle, it would go straight. Okay? If you think about this, we're constantly being, the Earth is spinning, we're constantly being kind of thrown off the Earth, and gravity holds us onto it. So there's always this idea of a force that's trying to hold you in while your body tries to go out. If it wasn't for the rotation of the Earth, we'd all be like slugs. We'd just lay on the ground. Okay? We would just be laying on the ground. But because there's this idea of this feeling of getting pulled out from the center, we can stand up. It also helps with something called artificial gravity, which we'll do a problem about that next time. This idea that you can make gravity feel like it exists without it actually existing. All right, any questions on the notes? All right, let's knock out this example problem, and then I'll give you time to finish the practice. Yes. I put string in the pig lab.